Hey guys, how's it going? In this video, I'm going to go through a universal solution that we can use to solve for this basic calculator type of decode problems. I know a lot of people, including myself, have been struggling those basic calculator problems, and that's the purpose of this video. As you can see, so this solution works for basic calculator 1, basic calculator 2, and basic calculator 3. So basic calculator 1 is actually a hard problem, and basic calculator 2 was asked by Facebook for 48 times. So I think there is some value to go through this solution in the video. So let's dive in. I'm gonna dive in straight to the basic calculator number 3 because it's basically covered the two basic calculator 1 and 2 already. Um, so let's dive in. So we need to implement a basic calculator to evaluate a simple expression string. So uh, and there are some wording in here. I'm not gonna go through that with you. If you want, you can read it by yourself. I'm gonna dive straight into the examples. So the string that we are given is a 1 plus 1, and then the result is gonna be 2 as an integer. Next one, 6 minus 4 divided by 2. So we have to do 4 divided by 2 first, and then put a negative sign in front of it, so it's negative 2. So 6 minus 2, which is 4. And this one looks pretty complicated, and so let's look at it piece by piece. So when we have brackets or parentheses, we do them first. So for example, 5 times 2 is 10, plus 5 is 15, and then times 2 divided by 3. So we get the first part, and the second part is 6 divided by 2, which is 3, plus 8, which is 11. And add the two pieces together, we get 21. Same idea for this guy, and this one is just as a number. There's no mathematical operations. And yeah, so there are companies asking this in the past 6 months. Let's dive in to the solution. Again, so this is the same solution that works for basic calculator 1, 2, and 3. So we're gonna solve this using a stack. Okay, and so I did a little bit of a research on the decode discussion board, and this is how we're gonna solve this. So the idea to use both a stack and recursion, which can be seen in two stack, because recursion uses implicit stack. And first, let us consider we do not need any brackets. So for example, we given an example looks like this, right? 1 times 2 minus 3 times 4 divided by 4 times 5 plus 6. So the way we're gonna do this is we have a stack. Looks like this, 1 times 2, which is the first part. The next one is going to be negative 3 divided by 4 times 5, which is the second part. Last piece is going to be 6. So what we're going to do is these steps. And after I walk through this algorithm with you, we're going to formalize it with as a code. So we put 1 into the stack. So the stack currently have a 1 as a number. And secondly, when we scan through, the next one is going to be a time operation, right? And here we pop off the last element and then times the new element, which is 2. And now the stack looks like 1 times 2 as a number, which has no single number still. And now the operation equal to a negative sign over here. And we put this number, negative 3, to the stack. So right now it has a 2 elements, which is 2. And then the next element is negative 3. And now when you keep scanning, the next one is going to be a division. So we pop off the last element from the stack. So now the last element becomes a negative 3 divided by 4, right? And then the next one is going to be times. So the last element becomes negative 3 divided by 4 times 5. Okay, so now we finished the first two pieces, and the last one is just 6 as a single number. So at the end, we have a stack looks like this: 1 times 2, which is the first piece. Second piece is negative 3 divided by 4 times 5. Last piece is 6 as a single number. And at the end, we just sum it all up on the stack, and then we return the result. And when we have parentheses, and we're going to recursively call the function that we're going to implement, I think now after we understand the basic algorithm, we're gonna dive into the code. So let's check out the code. The update, actually, this is how we work with the stack. I'm gonna go through it later when we actually need it. So this is a cal function where we cursively call this function whenever we either we started the function or we come across a parenthesis. So yeah, so this is what we're going to be cursively call this guy, and we have the current sign. Okay, let's walk through walk through the code with a concrete example. Okay, maybe we can choose this guy right here. So we have current sign. As a default, we have a plus sign. Also current number default is 0. Has a stack that we're gonna work with. So the I index is gonna scan through the given string, right? We have a character that has a look at the I index of the string. If the current character is an empty space, right? We just move on to the next index. And else if the character is a digit, and we basically what we're going to do in here is to append the pi number by times the pi number by 10 and then add the current number. So the reason why we keep doing this was for example, we have a number let's say 345, right? So we come across the first number, and then when we come across the second number, which becomes 34, so we times the first digit by 10 and then append the newest number we come across. And the last one, 345, so we times the 34 by 10 and then add the latest digit, which is 5. So at the end, we will have 345. Okay, and then next step, what we're gonna have is the else if the character is in either plus minus times on divide, so either this mathematical division, we're gonna update. It's just called this update function, and then what we're gonna update is the current sign that we have actually before we come across this. So this is the trick, okay? Essentially, what this is going on is, yeah, I spent quite a bit of time to understand how this works, but bear with me. I'm going to try my best to explain. So, for example, when we come across a times sign or come across the divide sign, right? So we're gonna do everything comes before that. Okay. So I think this may not be the best example to explain. Let's say let's give an example like 345. That's exactly what we had before, right? So and then plus and 3 divided by, let's say 3 divided by 1 or 2. Okay. So or we can 2 times. That's yeah, times is fine. So we have to add and have something before that. So when we have, let's say when we come across this multiple sign, so we're gonna work. So the last sign, the current sign that we had before this multiply sign, it was the plus sign. So what we're gonna do is update with the current sign, which was the plus sign, and we have the number. Current number is gonna be 345. So we're gonna update these two pieces and then put that into the stack. So that's why we have the update, and current sign actually is before the multiple sign that we are at right now. And then after that, after update these pieces, we update the current sign to be the current character, which is in this case is going to be a multiple sign. And then we put the current number put back to the default, which is 0. So now let's look at update. Okay. So if the given operation is a plus, we just directly append the number to the stack. And if that given operation is negative, is a negative sign, you just append the negative number to the stack. And if that given operation is a division, we actually pop off the last element from the stack and then divided the given operation. So basically, when we have the division, we pop off what we had already in the stack, which is this part over here, and then divide it by the number and take the integer of it, because in all the example that we have been working with is only in working with integers. That's why we convert it back to division. We don't work with decimal place. So, and same for the multiplication. So we just pop it off the last element and then times the given value. And then after we do the updating, we update the current sign that I discussed before, and then also push the current number back to the default, which is 0, and we move the index by 1. Okay, so the next thing I'm going to discuss is what happens if we come across parentheses. Okay, so we're going to recursively call this function cal. So, but the index, so actually the cal function takes in the index, which points to the index of the array, the string. And because now I come across the left parenthesis, the next index is going to be I plus 1. And when we return, it's going to be the numbers calculated within the parenthesis, also the index that comes back. Okay. So I think it's easy to understand this by looking at the next else statement. So after we have all this else statement, the else is gonna be the close parenthesis. So essentially, we are calling the update on the current sign, also current number, and at the end we don't have to do the rest. You don't have to go through the rest of the string. It's directly return the current. So the current sum in this case is the element within the bracket, and then also the index. Because in the next call we just skip through. So essentially, let's say if the contents in the bracket looks like this: 3 plus 4 plus 5, and we recursively call this guy. So we're gonna return all. So this current sum is gonna be like 3 plus 4 plus 5, and then the index is gonna be this guy over here. And then we move on to the index by plus 1. Okay, I hope I'm making myself clear. So at the end, if there's something left in the current sign, also current number, we also update it to the stack, and then we just sum it up on the stack. And yeah, so this, I go through this problem for time complexity goes a big O n, because we basically scan through the entire string once, and also for space complexity gonna be big O1 as well, big O n as well, because we only need stack to do the operations. So again, so big O n for both time and space complexities. So this is my solution to these to 3 of these problems. I hope you find this helpful. Thank you so much for watching. See you next one.